this is a video on solving one-step equations. We're going to focus primarily on that one step being subtraction right here. And so all of our equations that we solve here are going to be subtraction. So the very first thing we need to talk about when we're solving is opposites. And opposite numbers are numbers that add to equal 0. So examples of that are 3 and negative 3. If I take 3 plus negative 3, I get 0. If I take 10 and negative 10 and I add them together, I get 0. If I take negative 158 and positive 158, I add them together, I get 0. So in other words, a positive and a negative of the same number are going to add up and equal 0. So opposite numbers are important in solving equations because they allow us to move numbers from one side of an equation to the other. And so this word move is a word that I will use, but what I really mean is that I'm adding together opposite numbers. The next important piece is equations. Equations have an equal sign, and it implies that there is a balance. So when two things are equal, they are in complete balance. And so I have this picture of a balance here. So how do we use opposites in equations? We must use opposites to keep our equations balanced. For example, what number plus 6 equals 8? So I've chosen to use circles here as positive numbers and x's as negative numbers. So what number is a question mark? We're not sure. Plus 6 is going to equal 8. And so we can use opposites here to help kind of demonstrate this. So if I have one circle, I'm going to add to it one x, which is a negative. So I've got an opposite, an opposite, an opposite, an opposite, an opposite, and an opposite. So if I have 6 positives and I've got 6 negatives, those are going to combine to give me 0. Over here then, I can cancel out each of these pieces as well. One circle gets canceled with one x each time. They're opposites. So I'm taking 6 and I am taking away 6 and they're opposites, and that's what's left. So I have what number plus 0 equals 2, and that number then is 2. So you can kind of see in our balance here, whatever I did to one side, okay, I added 6 negatives. I had to add 6 negatives to the other side of my equal sign, because my equal sign right here is kind of like my balance, and I'm going to keep everything in balance by doing the same thing to both sides of my equal sign. So here's an example. It says you have some coins. You find 5 more coins in the couch cushions. You now have 13 coins. How many coins did you have? So again, you have some, you find 5 more, you now have 13. Okay, that can be represented in the following situation. You've got some coins, we're not sure how many. You add 5 to it, and now you have 13. So I've got 13 there. Okay? Now, if I want to keep everything in balance, but I want to know what number is going to be represented by x here, I know that I can start to cancel these out. So I would put an x, an x, an x, an x, and an x. And I know I've canceled out all 5 of those. But since I added 5 x's over here, I'm actually going to need to put those over here as well so that I keep everything in balance. Okay, so this is my number of coins, and I'm going to put that down here. It's what's left. These all cancel. These 5 cancel. And right here are the coins that are left. And I can count those up. I've got 1, 2, 3, 4, 5, 6, 7, 8 coins. Okay? So that's kind of a visual of how this works. We don't have to draw out circles every single time, and especially when we get something like this. It says you have a collection of pictures of Zac Efron. You recently added 3 pictures to your collection. You now have 256 pictures of him. How many pictures did you have of him? Okay, well here's the thing. We don't want to draw out 256 circles. That's not efficient. So I know based on my opposites, that if I have Z for pictures of Zach plus 3, because that's how many I just added to my collection, and I've got 256 now, that I can use opposites, because I need that 3 to become a 0. I need it to move to the other side. So again, if my equal sign is here, this is my balance. Whatever I do to one side, I'm going to do to the other. And so I know that Z plus 3 minus 3, those 3's are going to cancel and become 0. So it's like they're not there. And then 256 minus 3 is 253. Oops, and I'm going to label that pictures. Okay, so we're using opposites to solve, and when I get them to cancel, and I know that 0 is there, I know I just have my variable left. Okay, for this one it says solve the equation, show your work. So I've got k plus 17 equals 27. Again, here's my variable. I want to get this 17 to move to the other side. I know that I have to do the opposite of it, which is subtract. So 17 minus 17 is going to be a 0, and I'm left with k equals, and 27 minus 17 is 10. So we're solving one-step equations, and we're using subtraction. So again, here's my variable. I want to get that by itself. I know that I have p plus 20 equals 8. I need to do the opposite of positive 20, which is subtract 20. So these are going to cancel, and p is going to be left. I'm keeping everything in balance because my equal sign is right here, so I'm subtracting 20 from one side, subtracting 20 from the other, and 8 minus 20, this time I have to be careful, so I'm starting at positive 8. I'm going 20 in the negative direction. I'm going to end up at negative 12. And we've got our answer. Okay? So that's a little bit on solving equations, one-step equations, using subtraction.